Okay, section 7.3 is on solving quadratic equations using the quadratic formula. And so far we've learned how to solve quadratic equations using graphing and equations that could be factored. Graphing though can be a little bit of a pain because you might not be able to draw a real accurate graph and it might be hard to read the x-intercepts as solutions. If you're using factoring, that might also be a problem, especially if the equation is not easily factorable. So this formula that we're going to learn is a formula that can be used to solve any quadratic equation of the form ax squared plus bx plus c equals 0. And the formula is basically this, where a represents the number that's in front of x squared, b represents the number that's in front of x, and c is the constant of your equation, written again in this form, ax squared plus bx plus c equals 0. It has to be written in that form to be able to use this formula, and it has to be a quadratic equation. So it has to have an x squared term. It can be missing an x term or a constant, in which case the b or c would be 0, but it has to have an x squared term to be able to use that formula. Alright, so let's try some examples. So the first equation says to solve for x, given 2x squared plus 8x minus 5 equals 0. So that is in the form that we want, and in this case a would be 2, b would be 8, and c would be negative 5. So if we use our formula, we would have x equals negative b would be negative 8 plus or minus the square root of b squared, which would be 8 squared or 64, minus 4, a would be 2, and c would be negative 5, all over 2 times a, which is 2 times 2. And then we just simplify that as negative 8 plus or minus the square root of 64. Now, this is a minus and a minus, so they're going to be multiplied to give you a plus. And 4 times 2 is 8, times 5 is 40. So it'd be 64 plus 40 over 4. Run out of space there. Okay, so one more line there. So this would give you negative 8 plus or minus the square root of 104 over 4. Now, there's two ways you can write the answer. You can write the exact form, which would be to keep it in radical form, which would be negative 8 plus or minus. And if you factor 104, just got to come over here and do that. 104 would be 2 times 52, which would be 2 times 4 times 13. So basically there's a perfect square factor of 4 times 2 times 13 is 26, all over 4. And then that would give you negative 8 plus or minus. The square root of 4 can come out as a 2, leaving you with 26, which has no other perfect square factors. And then this would be negative 8, oops, not negative 8. When you look at this number, and this number, they all have a common factor of 2, so that would mean 2 goes into the top negative 4 times, it goes into that once, and it goes into that twice. So you would have negative 4 plus or minus root 26 over 2. So x would equal negative 4 plus root 26 over 2, or x would equal negative 4 minus root 26 over 2. Now, that's the exact answer, but you could also have the approximate answer, which would just be plugging these into your calculator and getting the approximate answer. X is approximately negative 4 plus the square root of 26, and then divide that by 2, which is approximately 0.54, or negative 4 minus the square root of 26, and divide that by 2, and you get negative 4.5455 if I round it off. That would actually be 0.55, the last one as well. That would be 0.55 as well, sorry. When I look back at my calculator. Okay, so those would be the approximate answers, and these ones here would be the exact. Those would be the exact answers. Now that's not a real nice one to start with. Alright, so the second one there, for determining the roots, the first thing you got to do is make sure the equation is in the proper form. So we'll bring everything to one side, equal to 0. So that would be 6x squared, and if the 7x comes over, it becomes minus 7x, and then you still have the negative 3 on that side of the equation, so it stays negative. So in this case, your a is 6, your b is negative 7, and your c is negative 3. So your quadratic formula says the solutions to this equation can be found by putting them into the formula, and the formula is up at the top of the page, so I'll write it again. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So that would equal negative 7 is your b value, so the negative of negative 7 would be positive 7, plus or minus the square root of b squared would be negative 7 squared, or 49. Because a negative squared is going to be a positive, right? Minus 4a is going to be 6. C is going to be negative 3. All over 2a is going to be 12. So that's going to give you 7 plus or minus the square root of 49. Again, you have two negatives being multiplied, this negative and this negative, so it's going to be negative 4 times 6 times negative 3, so it's going to become plus 24 times 3 is 72, all over 12. So again, they're not real nice answers here. So it's going to be 7 plus or minus the square root of 49 plus 72, which is 121. Oh, this one works out nice. All over 12, which gives you 7 plus or minus 11 over 12. And that means that x is either 7 plus 11 over 12, which is 18 over 12. Do I have any more space there? Which is 6 goes into both those. So 6 goes into 18 3, so it goes into 12 two times. Or x is 7 minus 11 over 12, which is 7 minus 11 is negative 4 over 12, which reduces to negative 1 over 3. So those are your two solutions. Now when you get numbers that work out nice, like the square root here worked out to be a nice number, square root of 121 was 11, that means it could have been factored as well. So the next one, again, is not set up to use quadratic formula first yet, the way it is, so you have to distribute that 5x, and that will give you 5x times 5x is, 25x squared, minus 5x times negative 2 is 10x, equals negative 1, and then bring everything to one side so that the equation equals 0, and you can use quadratic formula. So the formula again is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we start substituting in the b value in this case. A is 25, b is negative 10, c is positive 1, because we've got to read it from this form right here. So the b is negative, so the negative of negative 10 would become positive 10, plus or minus the square root of b squared, which would be negative 10 squared, which would be 100, minus 4a would be 25, and c would be 1, and that's over 2 times 25. because the a value is 25. So then that becomes 10 plus or minus the square root of 100 minus 100 all over 50, which becomes 10 plus or minus 0. Square root of 0 is 0, all over 50, which is 10 over 50, because 10 plus the 0 is the same as 10 minus the 0. So that's 10 over 50, which is just 1 over 5. So there's only one solution there. And the last one there on the page. I just move that up. We have 4x minus 12 equals 3x squared. So I'm going to bring everything over to the right side of the equation where the x squared is a positive. So that becomes minus 4x plus 12. And then we can go right to our quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. Because we have the equation set equal to 0, so we know now that our a is 3, our b is negative 4, and our c is positive 12. So this would equal, again, negative for the b means the negative of a negative would become positive 4, plus or minus the square root of b squared would become 16, minus 4, a is 3, c is 12, all over 2 times 3. And that's going to give you 4 plus or minus the square root of 16 minus 144. 4 times 3 times 12 is 144, all over 6, which is going to give you 4 plus or minus the square root of 16 minus 144 is going to be a negative 128. So, if you know anything about square roots, you know that this means it's non-real solutions, because you can't find the square root of negative. In the set of real numbers, it won't work. So we don't need to continue there. This is as much as you need to do. Just say that it's non-real solutions. Okay, so if we look back at the last few examples that we just did and summarize the results in this table, we can see if we can come up with a way to figure out how many roots we'll have when we're solving a quadratic equation. So the first one we solved was 2x squared plus 8x minus 5. If I look back at the solutions for that, we had the roots were x equal to negative 2 plus or minus the square root of 26 over 2. So there were two roots, negative 2 plus root 26 over 2 and negative 2 minus root 26 over 2. Now the value of b squared minus 4ac was not originally 26, which is what's under the root sign there now. It was actually 104 originally when we go back, because it was b squared, which was 8 squared minus 4 times 2 times a negative 5, which actually works out to be 104. So this would be a positive. Is it a perfect square? No. Non-perfect. Square root of 104 is not a perfect square. The second one, when we worked out that one, we ended up getting two answers of 3 over 2 and negative a third. And there were two roots, and the value underneath the square root sign was 121, which was also a positive, and it was a perfect square. And the next one, when we worked it out, we ended up getting one root, right? It was just 1/5. So there was only one root, and the value of b squared minus 4ac was 0. So this would be not positive or negative, and it would be a perfect square because 0 squared is 0. And the last one, we ended up with no real roots because we ended up with a negative under the root sign. So the number of roots would be 0, because when we're talking about roots, we're talking about real roots. And the value of b squared minus 4ac was, I believe it was negative 128. So this would be negative, and it would be a non-perfect square. So the value of b squared minus 4ac reveals a lot of information about the types of roots we're going to get. If you look back at our samples there, anytime the value of b squared minus 4ac was a positive, we ended up with 2 real roots. When we had the value of b squared minus 4ac being a negative, we ended up with no real roots. And when we had the value of b squared minus 4ac equal to 0, if we look back in our table, we ended up with just the one answer because the two of them, remember, were exactly the same. We ended up with 10 plus 0 over 50 and 10 minus 0 over 50, which gave us, both cases, gave us 10 over 50 or 1/5. So if the value of b squared minus 4ac is greater than 0, we can assume that we're going to get 2 real roots that are going to be distinct x-intercepts, so 2 unequal real roots. And they would show up as 2 x-intercepts on the graph. If you end up with a perfect square underneath your root sign, then that means it could have been factored, the quadratic equation could have been factored. If it was a non-perfect square, then that means that you wouldn't have been able to factor the quadratic equation to solve it. If you end up with b squared minus 4ac that's negative, that means you can't find the square root of the negative when you're trying to do the quadratic formula, so the equation will have no real roots, and therefore no x-intercepts. So the graph, if you look at an example graph here, it would never cross the x-axis. And the last type is if you end up with a value of b squared minus 4ac that was 0. That means the stuff under the root sign would still be the square root of 0, which is 0. So you'd end up with 2 answers. You'd end up with 2 answers that were exactly the same, negative b plus the square root of 0 over 2a, when you did the quadratic formula, and negative b minus the square root of 0 over 2a, which are going to both, in the end, they would both be the same value. They'd both end up being negative b over 2a, whatever that is. So in this case, if you had a graph that's touching the x-axis at the vertex, that means there's going to be a 1 solution, 1 x-intercept, or 2 real and equal roots. So if you're asked to describe the nature of the roots for these quadratics, you basically only want to figure out what b squared minus 4ac is, the stuff that's underneath the root sign in quadratic formula. So in this case here, b squared would be negative 8 squared minus 4ac, which would be 64 minus 40, or positive 24. So this is a positive, which means we'd be expecting 2 real and different or unequal roots. The second one is not written the right way. First, we've got to bring everything to one side equal to 0 before we can figure out what b squared minus 4ac is. And then b squared minus 4ac in this case would be negative 1, would be the b value, squared, minus 4a would be 1, and c would be 10. So that would be 1 minus 40, or a negative 39. So since this is negative, that means there'd be non-real roots. And the last one if you bring it all to one side, bring that 4x over, becomes minus 4x plus 1 equals 0. And we work out the b squared minus 4ac value. We get negative 4 squared minus 4a is 2, c is 1, which would be 16 minus 8, which again would be a positive. So therefore there would be 2 real and unequal or different roots. And the only case we didn't cover there is if you had b squared minus 4ac equal to 0, of course you'd get real and equal roots. So there's some more questions there in a quadratic equations worksheet that I have that you can do for practice.